Hey, so I just want to make a little video showing some recent, not really research, but just a little project I've been working on that I might try to turn into a paper lately. That I think's been really fun, and I've been enjoying this coding more than a lot of other things lately. So I thought I'd make a video and describe the project. Um, so basically, there are these things called height maps that we use in video games and movies and other things that have a terrain where we model the Earth, basically the ground of the Earth, using some kind of object here. Um, to make these terrains, we use a height map, which describes the height at all these locations. Right, we can see that there are mountains here. Maybe this is more of a basin down here. And these are all described with height values and elevation values. Um, and we can actually look at actual height maps from the Earth, and these are a few examples of what those look like. And if I just scroll through them here, you can kind of see they look kind of like lightning or tendril-like. If we take a look at this, we can see that this is likely a valley that comes through. It's a pretty deep valley compared to what's around it, because white means higher and black means lower. And so continuing to look through a few of these, we can see mountains have these peaks here. This dark area is much lower, and we're seeing it spread into these mountains that are much higher on these ridges. But we're seeing these kind of cool features, and this is actually all taken from satellite imagery of the Earth using things like LiDAR and other technology that are able to capture the exact height in meters for each part of the Earth. So this is really cool, and we have a lot of this data. And you know what likes a lot of data? Are neural networks, which is actually what I've in part been researching in my PhD studies. And so I decided to apply neural networks to over 15,000 height map images from North America. So all of these images I've taken from North America, and I've trained a neural network to create new height maps that look like they belong in North America. And so the neural network that I created has accurately been able to do that. And so that's actually, it's cool to hear by itself, but it's actually not novel. It's not something that would wow anybody, because neural networks are really good now and they can do just about anything. But there's a lot of open questions, and how we use them is more of the important thing, and when we can use them, and making sure they're trained properly, and understanding why they're creating what they're creating. And so to actually make this neural network useful, I'll just show you now. I'll connect to it, and I'll just get some random height maps. So down here, this is a random height map that it made. I can press this again. There's another random height map it made. This is another random height map it made. You can see these all look really, really realistic and have features from our original data set. There are a lot of controls that we can have that aren't normally exposed, which I tried to expose in this little tool that I made in this game engine called Unity. So for this recent research that I guess it's not research, more of a project, but I want to allow designers and artists in game engines to be able to control exactly what kind of realistic height map they can get from this neural network, because it's already given. This neural network is going to create really cool output, but we want to we want to have art direction over this neural network output to tell it what exactly we want. And so I did that through a few ways. Technically speaking, there are a number of loss values and rules that I can find how incorrect a current height map is, and tell the network, hey, this is how incorrect you were. Figure out how to fix yourself. Technically, this is done through backpropagation and gradient descent. And eventually we fix the neural network to give us a correct output, without actually changing the neural network. We're keeping the neural network saved. It was already trained to make good output. We're keeping it the same, but we're able to change some other things around it. We won't get into the details. Let's do an example here. I'm going to add a rule here for exact height, right? This basically lets me draw exactly what I want. So let's say I want to have a mountain range kind coming in from the bottom here on the left, and I want it to come over here and maybe go up to the top corner here, right? So I'm just gonna draw, it's just gonna be like this, okay? And everything else I want to be low, right? This, I'm gonna delete that. I want it to be black. I want it to be very low, okay? So I'm gonna look at the height map here so you can see it working. I'm gonna hit train, which is telling the height map, or telling the neural network, this is what I want my height map to look like. I hit train, and it's slowly learning. Oh, I'm orientating correctly. That is the output that I want, right? So here's an example of something that I gave back. And it's close, but it's not perfect, right? So we're seeing, yeah, it is low on the right side. It is high on the left side, but there's this little gap here where it's actually jutting in. So maybe I can fix that by making this even higher and filling a little bit more. I'm going to hit train again. I'm going to keep telling it to try to fix itself. And again, it's getting a little closer, a little closer. I'm going to train again. Let's see if it can get even closer. Yeah, so this is pretty good. This is about what I want, right? It's pretty close to what I drew here. Let's try another one. I'm going to randomize and then remove that. Let's try to make, I'm just going to make a kind of mountain, right? So a mountain is low on the outside, or one mountain peak, and then it gets a little higher, and it gets a little higher, all the way until the middle where it gets really high, right? So I want to make one mountain peak. Let's see if I can train it to do that. And sure enough, we can see that after training, we basically get one mountain in the middle. Of course, it's not perfect because this is more of a guidance. This is kind of telling the network what I want it to look like. And from there, we can do more post-processing, more kind of tweaks and changes afterward. Yeah, there are a lot of other rules that I created. So exact height is just one of them. The other things we can do are raise parts, we can lower parts, we can add ridges, or we can smooth out areas. We can also change the alignment, so we can make something more vertically or horizontally aligned. All of this is done through mathematics and backpropagation and high-level calculus stuff, but I'm just going to hand wave over all of that and say, yeah, you guys are smart. You know what I'm talking about. For the neural network, there are a number of controls that I have actually. This is during the generation of the height map in the neural network. There's a lot of controls I get to tweak. Kind of going to gloss over that, but that's another really cool part where I can individually change the styles for every level during the generation process, which is another really cool thing. For those curious, this uses something called StyleGAN2. And if you go to a website called thispersondoesnotexist.com, this person and this image, this is kind of a bad one actually, but this face doesn't exist. This is not real. This was made by a neural network. Every time you refresh the page, you get a new face, a completely new person. This person does not exist in real life. It was dreamed up by a neural network. This boy does not exist in real life. This uses the exact same neural network that drives that. Yeah, there's a lot of things, a lot of great techniques involved that allow that to work so well. And we get the same kind of exposure. So there's a lot of artistic control we can get in the generation process that I'm not going over right now. But yeah, I just want to share how cool this is. It's been very exciting to work on. Just a fun project, and yeah, maybe some designers would find it useful. I think it's really helpful for beginners to be able to just jump in and especially the sketching part, just be able to sketch any kind of height map that they might want for their level, for their rendering that they're trying to make in Houdini or Maya or whatever else, just to get something going and see it right away as it's trying to do it. Maybe they find something they like and they're able to pick and choose that height map. Yeah, thanks for listening. Hope you found this kind of cool. I really just think neural networks and applying them to video games and visualization is really neat. So yeah, thanks for watching.